My name is Niketan Dovaria, and here we are discussing basic electrical engineering, in which we are discussing chapter number 5, electrical installations. So, up to now, in our previous video, we have discussed various protective devices like MCB, MCCB, ELCB, and various earthing methods. And as well as we have discussed construction of wires as well as cables. So, in our today's video, we are going to discuss our next topic, and that is batteries. So, before we start batteries, let's understand the basic difference between what is cell and what is batteries. So, here we have difference, or you can say a comparison of cell and battery. Basically, cell and battery both are almost same thing, but still there is a minor difference between these two. And let's find out this difference over here. So first one, let's start with the definition. What is the definition of cell over here? So that is a single unit device which convert the chemical energy into electrical energy. We know that what is the battery or cell basically. Basically, this is applicable for both cases when we define cell or battery. So cell or battery can be defined as a device which converts chemical energy into electrical energy. So that is cell or battery. But difference over here is when we define cell, so that is defined with this single unit. So that means output of the single unit is going to be very less. So what amount of electricity we are getting out of that cell is going to be very less with compared to battery. So what is battery over here? So it is a collection of electrochemical cells which either connected in series or parallel. So as I say, by using cell, when we convert chemical energy into electrical energy, we get very less voltage as well as the current. But if we want to increase the voltage or current, basically if you want to increase the output, so what we can do over here, we can connect the cells in a series connection if you want to increase the voltage, and we can connect these cells in parallel connection if you want to provide the higher current. And basically if you want to increase both voltage and current, so we can provide both type of connection simultaneously, series as well as parallel. So basically cell is an individual device, individual portion which convert chemical energy into electrical energy, and battery, that is nothing but a combination of various cells in form of series or maybe parallel connection. Now next one is that's the symbol of cell and battery. When we use a cell, normally we use this symbol with one device, and when we use battery and combination of cells, we use this type of symbol. And these are the various types of cells over here. First one is a dry cell, wet cell, reserve cell, and fuel cell. Same way, here we have a types of batteries over here, the primary battery and secondary battery. Now, next, if we compare based on specification or structure, so for cell it's light and very compact, and while battery is very heavy as this is a combination of more cells. Now power, it supply power for short time period while battery can supply power for long time period with compared to cell. Now here we are having various application of cell, and that is clock, lamp, radio, remote control, and various devices like this. Basically, it's small devices, and batteries. It is used in automobiles, inverter, emergency light, and many more. If we compare the cost of these two, so it's normal. We can say that cell is going to be very cheap with compared to this battery. So this was a comparison between cell and battery. Now, from this comparison, we have just got to know that cell and batteries are basically same thing, but battery is a combination of more cells in series or parallel connection. So based on this, let's move towards our next topic, and that is primary and secondary cell. Or basically, you can also define primary battery or secondary battery. Now, let's define what is a primary cell. Let's find out over here. So, what is primary cell or battery? Is one that cannot easily be charged after one use and are discarded following the discharge. So basically, in simple way, I can say that when we use primary cell, you can use it only one time. If you want to charge again after using it, then it's very difficult. So instead of charging it again, it is beneficial or it is easy to design another primary cell and use it again. And what is secondary cell or battery over here? So secondary cell or battery is the one that can be recharged after the use of that or original pre-discharging condition. So basically that means that when first of all you charge this secondary cell, you use it, basically you discharge it, and after discharging it you can again charge it and again use it. This is the basic difference between primary and secondary cell or battery. Primary cell that cannot be easily charged, so generally we don't use it again. And secondary cell or battery that can be charged easily again after using it or after discharging it. So you can use it again and again. So that's the basic difference between primary cell and secondary cell. Now, let's again move towards our next topic, and that is the various terms related to batteries. So here, let's start with our first term, and that is first one is the ampere hour. In short form, that is given by over here. In short, you can define AH means ampere hour. Now, what is ampere hour? Let's find out over here. Ampere hour is also known as the amp hour in short form, and it is the unit of battery capacity that measures the amount of charge that can be available in fully charged battery. We know that what is the relation between charge, ampere, and time. So I is Q by T, charge per time. So here we have a term I into time, current into time. So basically if you multiply current into time, so that provides the charge. So basically this parameter is defining the charge. And when we define the ratings of any battery in ampere hour, so that defines the ratings based on charge available on that battery. And we define this charge when it is in fully charged condition. So basically, when battery will be fully charged condition, at that time we will calculate its total charge, and that will provide the basically ampere hour rating of that battery. Now, if you continue on again, this amount of charge is what determines the amount of current that can be discharged from that battery and its discharging time. That means, another example, let's suppose that if we are having one battery and it is having 10 ampere hour rating. So, based on that, you can decide that if we use a particular amount of current, so that amount of current, so how much time you can use that amount of current for. So that will also define the discharging time based on particular discharging current. Other example, let's consider we are having a battery of 10 ampere hour, and if you are using application of 1 ampere from that battery, so here we are using the 1 ampere current, or we are taking the 1 ampere current out of battery, and its rating are 10 ampere hour. So if we divide the 10 ampere hour by 10 ampere, sorry, 1 ampere, so it will provide the 10 hour. So that means if we are collecting a current from battery with rate of 1 ampere, so that will provide the supply for 10 hour. Same way, let's say if we are collecting current with 2 ampere, so basically battery is providing current of 2 ampere to particular application, and ratings are again 10 ampere hour. So if we divide 10 ampere hour by 2 amperes, that will provide the 5 hour. So that means in this case now battery can be provide supply for 5 hours. So that define the capacity of battery to provide a particular amount of current for particular time by calculating the charge on that battery is ampere hour capacity. Now let's define the another parameter, and that is watt hour. Now, what is watt hour over here? So, watt hour is abbreviation of watt hour can be defined as a WH, watt hour. Now, it is referred to as a energy capacity of the battery, as it is more accurately determine the energy that can be stored in that battery. Okay, now next parameter is watt hour, and we know that when we multiply power with the time, that provides the energy. So when we define the ratings of batteries in form of watt hour, so basically here we are calculating the total energy stored in that battery. And same way as we had discussed for ampere hour, it is the rating of battery which will define the how much power will be supplied to particular application for particular hours. So in our previous definition over here, we had calculated that by this rating, how much current can be provided by battery for particular hours. Same way, this will calculate if we are providing particular amount of power. So for how much time that can be provided by that battery. So that can be defined by this second rating means watt hour. So these are the basic characteristic of batteries. Now, next we will discuss one of the battery over here, and here we are going to discuss the lead acid battery. If we discuss the basic construction of lead acid battery or any just general battery, so normally when we define the secondary cell or secondary battery, uh, which can be used after discharging again by charging it. So here, in basic structure, we will have a one container over here. So here we are having a container, and in that container, we will have a one electrolyte H2SO4 sulfuric acid, and that is mixed with distilled water. And if you find out the percentage over here, so here we have used 38% of it H2SO4 and 62% water. Now, so this will form a electrolyte material over here. And to form a positive and negative terminal, we had used two plates over here. First plate that will be used for positive terminal. So that is made by lead peroxide means PbO2, and here we are having negative terminal which is made of pure lead, and that is Pb. So this is basic structure of this lead acid battery. And when any load will be connected across this positive and negative terminals, so that will provide the supply. So let's discuss how this battery will work. Means if we will connect a load over here, let's consider that if we are connecting a lamp across this positive and negative, so how this battery will provide the electricity to that lamp. So basically here we are discussing the discharging process. We are considering that battery is in charge condition, and now we are providing that chemical energy or that stored energy to this particular lamp. So let's discuss how it will provide the current to this lamp over here. So here, when this load will be connected over here, so the molecules of this H2SO4 will be break in hydrogen and this SO4 component. So basically, we know that hydrogen having positive charge and this SO4 having two negative charge. But here, normally, if we observe the equation of H2SO4, so we are having 2H. Basically, that will provide the two different H over here. But for this discussion, we are considering a one hydrogen compound. So, and it is having a positive charge over here. Again, this hydrogen will be attracted toward this, and here from this lead peroxide it will get a negative charge over here. So initially it was positively charged, and now when it will get a negative charge, so it will form a neutral hydrogen. Now these molecules of hydrogen will react with this plate of PbO2. And as I mentioned, from here we are getting the two hydrogen molecules. So these two hydrogen molecules will react with this PbO2, and as it will react with this two hydrogen compound, so it will form PbO over here, and it will discharge, it will also create a water over here, H2O. So that means here water will be added in this portion over here in this electrolyte. And once here PbO will form, what will happen? This PbO again it will react with the H2SO4 present in this liquid over here, and again when this PbO will react with this H2SO4, it will create a PbSO4 compound over here. So this whitish color material is nothing but a PbSO4, and again it will release the water again. So again the amount of water in this electrolyte material will increase. And if we observe the process at this cathode terminal, so what will happen over here? So here we are having SO4 minus compound over here. So basically that SO4 minus molecule will react with this plate over here, and when this SO4 minus will come in contact with this plate, first of all, it will provide its negative charge to this plate over here. So first of all, it will provide negative charge to this plate, and it will form a neutral SO4. And once this SO4 will form, and then it will react with this Pb. And once it will react with this Pb, so now it will form a PbSO4 in on this cathode terminal. And this whitish color material is representing this PbSO4 material. So basically, if we observe the equation on anode and cathode, so what we are getting over here on both plates, we are getting the PbSO4 layer. So when battery will be discharged completely, what will happen over here? This both plate will have a PbSO4 layer on this anode and cathode, and as well as on anode, it is also creating a water. So basically, when more water will be added in this electrolyte, so that will increase the amount of water, and that will decrease the basically H2SO4. So once the amount of this H2SO4 will decrease at below the certain level, so now it cannot provide the supply to this load. So basically, at this time you can consider now your battery is in discharge condition. Now, again, if we want to charge the battery, what can we do over here? So we can provide an external supply across the battery as shown in this diagram. So here we have provided a battery across this terminal of this our main battery. Now positive is connected with anode of our battery, and this negative is connected with cathode of this our battery. And once we will provide the supply through this battery, so what will happen? Again, it will break the molecules of this present H2SO4. So here, after the discharging of battery, H2SO4 level of H2SO4 will decrease, but it will not almost zero. So there will be still some amount of H2SO4 is present in this container. So when this current will be passed through Orion, so it will again break the molecules of H2SO4, and again it will create two hydrogen with positive and a negative SO4. Now, as this plate is positively charged by this battery, so this negative ion of SO4 minus will come nearby this plate, and this positive charge means positive ion of hydrogen will come nearby this one. And if we observe the chemical process at cathode, means at this terminal, what will happen over here? Here, as after the discharging of battery, a layer of PbSO4 was on this cathode terminal. Now this PbSO4 will react with this two hydrogen atom. First of all, it has a uh, it had a positive charge of on this hydrogen molecules, but that will be collected by this negative terminal, as this negative charge will provide the extra electron to this hydrogen, and when this hydrogen will get the electron from this negative terminal, so it will form a neutral hydrogen molecules, and when it will react with this PbSO4, so again it will create a Pb over here, and it will release the H2SO4 again. So once H2SO4 will release, so it will increase the level of H2SO4 again. So this is process on cathode. Now if we observe the process on anode terminal, so what will happen? Again we are having a layer of PbSO4 over here, and as the hydrogen sorry as the hydrogen molecules are also present, as well as the SO4 molecules are also present in this material, so this will react with PbSO4, and by reacting with these chemicals, it will create a PbO2 on this terminal, and it will release the two H2SO4 component. So basically, here we are getting the H2SO4 from anode as well as cathode. So it will increase the level of the H2SO4 again over here. So basically, it will create the potential difference on this plate again, as it was generated when we had charged the battery initially. So this way we can again charge the battery over here. Now, next is the various charging method of lead acid battery. This can be applicable for also other batteries. So, first method is a constant voltage charging. So, what is constant voltage charging? Let's discuss over here. Now, it reduces the charging time. In this method, the charging voltage is kept constant, and as we are considering charging voltage as a constant, that's why we have named this method as a constant voltage charging. Now, the charging current is high in the beginning when the battery is discharged in this completely in discharge condition, and current is gradually dropping off the battery, pick up the charging, resulting in increased back EMF. Here we are having a graph of charging current and charging voltage over here. This is a charging time period. Now, one more point, it allows the cell with different capacities at the different degree of discharge to be charged. The large charging current at the beginning of the charge is of relatively short duration and will not harm the cell. So here, if you observe this diagram, here charging current at initial time is very large with compared to when we consider after some time period. And again, at this time period, charging voltage is not always again constant, but this is for very short time period. After that, charging current is also decreasing, as well as charging voltage is constant for throughout the time. So we are not considering this time as this is a very short time period. For rest time period, voltage will be constant as well as current will be low with compared to initial current over here. But as I mentioned, one of the advantage of this method is it reduces the charging time. And now if we discuss the next method, that is a constant current charging, and as name indicates, here we are going to provide the constant current while charging the battery. So in this method of charging of the battery are connected in series, and we know that when we want to charge a battery with constant current, but at a time we want to charge multiple batteries, so we cannot connect multiple batteries in parallel connection. If we connect multiple batteries in parallel connection, so that will divide the current. So basically, that will not provide the constant current to different batteries. So that's why when we will use this method, and if we want to charge multiple batteries at a time, so at that time we will connect those battery in series connection, and after series connection we will provide this method to charge the batteries. So as they form a group, and each group charge from DC supply main through loading rheostat. Basically, why we are using rheostat over here? Because we want to maintain a constant current. When batteries will be charged, so once voltage across the batteries will increase, so it will try to reduce the charging current. But at that time, we will reduce the resistance of this rheostat and we will control the current, and again we will maintain the charging current of this battery. Now, charging current is kept constant throughout the charging period by reducing the resistance in the circuit. So, as I mentioned, when voltage will go up, so it will try to reduce the charging current, but we will reduce the amount of resistance which is provided by rheostat in that circuit, and by reducing resistance we will again maintain the constant current. And again, in this method the charge current is approximately 1/8 of its ampere rating. So here in this graph we can observe the charging current as well as the charging voltage. So charging current is almost constant over here, and charging voltage is increasing with charging time. So this was the second method for charging of battery. So this was all about batteries. Thank you for watching this video.